So let's get started by unveiling our three basic trigonometric ratios, which is the sine, cosine, and tangent. Remember, a trigonometric ratio, as the name suggests, is just a ratio to do with the sizes of sides and angles in triangles. These ratios are probably buttons you've used on your calculator but never thought about where they actually came from. So let's find out by jumping. The ancient mathematicians actually used to for fun investigates the properties of shapes, and some of their faves were circles and triangles even more. So they right angle triangles, you can imagine. They've realized how easy it is to put a right angle triangle inside a circle using a point and the circumference and the center as corners. So then what will they would study this and try to learn everything they possibly could about it, and anything in particular they tried to learn was the exact length of this line. And this line be because, as we can say, they change when we move this point around, and if we change this angle theta in our triangle to calculate the line lengths, they came up with the trigonometric ratios. These ratios define the sine of an angle theta to be this length, a divided by the length of the hypotenuse of the triangle, and cosine of theta be this length b divided by the hypotenuse, to do with something called the unit circle, which we'll look at in a few videos time. All we need to worry about is that they've made these ratios. They define the tangent ratio of theta or tangent theta to be the sine of theta divided by the cosine of theta. The reason being, if we use similar triangles and that unit circle thing, then the tangent of theta would be this length of the tangent. So these three ratios have been used for centuries now. So in the present day, we can drop the circle and just focus on the triangle in a right angle triangle. If this angle is theta, then the longest side, which is the one opposite the right angle, is called the hypotenuse. The other side is called the adjacent side because it's right next to our angle theta. And the other side, the one opposite theta, is called the opposite side. So using this, we can define our trigonometric ratios for any right angle triangle as the sine of theta equals the opposite side over the hypotenuse. The cosine of theta is the adjacent side over the hypotenuse, and the tangent of theta is the opposite side over the tangent side. These are three formulas you absolutely need to know out. Luckily, there is a sneaky memory trick, the SOHCAHTOA. What it's an acronym, SOHCAHTOA. The sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. These ratios only work on right angle triangles. These ratios are the backbone of this entire unit, so it's incredibly important you have them down. Let's round off by looking at a nice easy example. Let's say we have this triangle and we need to find firstly the size of the angle theta and then the length of x. Because this is a right angle triangle, that means we're allowed to use the trigonometric ratios we just learned about. Now, convenience. So what we need to do is see if we can find any of these trigonometric ratios using theta, this triangle. So we do sine theta is 30 over 34 because sine the opposite over the hypotenuse, that's the sort of SOHCAHTOA. Now, this doesn't tell us the size of theta, it just tells us the sine of theta, so we need a way to get rid of the horrible sine bit. And unfortunately, we can't just divide both side by sine. What we can do though is take what's called the inverse sine of both ideas, both sides. You don't need to worry about how this works, but what is important is that the inverse sine of the sine of theta is just theta, and there are inverse for cosine and tangent as well. Now, when we do this, we take the inverse sine of both sides. But don't worry, there is a button in your calculator that will help you. That's mean theta equals the inverse sine of 30 over 34, which equals 61.93 degrees. Now, to find the x, we need to add another trigonometric ratio, one that has an x in it, because we'll use our other information to find this value. Let's use cosine. We can see the cosine theta equals x over 34, and that means x equals 34 times cosine theta, and sine, we know theta equals 61.93. From the last question we can check 34 times cosine 61.93 into our calculator, and we get 16, and that means we're done. So that's how we use trick to find a side under 9. Absolutely, this might seem pretty easy. It's really important we nail down those foundations, and that's all we're going to cover in this region. So that's all. Thank you.